Hello, with this video, I wanted to go over section 2.5, transformation. This will help a little bit with this section, working in my Math++ and maybe some of the bookwork. The first thing, these are the slides that I posted in Moodle. The first slide shows that these are called the base functions. We have y equals x, which is just a straight line, x squared is a parabola, and so forth with the square root. So these are called our base. These is the base function that we're going to use, and we're going to actually do some transformation of this original function, and then do some shifts, either up, down, make it shrink, or make it expand or stretch throughout the whole, or reflect on the x and y axis. So here are a few examples. The black one always shows the original function, which is noted in gray here. So y equals 1/5 x to the fourth. And notice that it shifted up how many spots? 1, 2, 3, 4, 5. And it shifted up for the red, it shifted up 5. So what does it mean when it means to shift up? If you look at the function, notice that the variable plus b is on the outside of the function. The same thing here. Here's my original function, and then if I have plus 5, which is this is my function here, and I have plus 5, you see that it shifted up 5 spots. So here again, here's the black of the original one, but this time it went down 3 times. So anytime you have a function on the outside of the function, minus or plus, we're going to shift up if it's plus, and then down if it's minus. And this will be called a vertical translation. A horizontal translation is, notice where the numbers is located now. It's inside with the x. So before it's on the outside of the function. Now we're going to put it in parentheses inside of the function. This is where we shift either left or right. So here again is our original function, 1/5 x to the fourth. And here we see a minus sign. So this is kind of confusing because when we think minus, we want to go to the left because that's where the negative is on the x-axis. But this one here, you want to be careful and make sure that we're going to the right this time when it's inside of the function with the x. So minus 3 means we're going to shift over 3. 1, 2, 3. And then we put the 4, the exponent of 4 still up top here. So here again, here's our original function, and then this is a plus 7. So the plus means we're going to actually shift left this time, 7, all the way over here to the 7. So this is what a horizontal translation looks like. So here are the reflections. If you want to reflect across the x-axis, the negative sign will be in the front of the function itself. If you want to reflect across the y-axis, then it's going to be inside with the x, like we did we talked about before with horizontal translations. And so a few examples. So here's the original one that we've been discussing in this section. And then if we put the negative on the outside, we see it reflects across the x-axis. So here my original one, this time I have 2x to the third minus x to the fourth plus 5. And for each x, I put a negative sign in front. Now this means that we're going to reflect on the y-axis. So here's my original black line. And now I'm going to reflect over the y-axis because the negatives are in the inside. So vertical stretching and shrinking. If you have a whole number, a, which is going to be the a is going to be constant, is going to be in front of the function being multiplied to the function. If you have an a on the outside and it's a whole number, this is where we're going to be vertically stretching. So looking at the examples here, the black again is the original. And you see if we put a 2 in front, it kind of pushes it and makes this hump a little bigger and this one a little bigger also. So we kind of stretch it vertically. So think about you pulling something up and down. If I pull this hump of this vertex up and this vertex down, I'm stretching it. So with the negative here, again, we reflect on the x-axis, and then with the 2 again, we're going to pull this vertical up and then pull this one down and see how it stretches it. Now, if I want to shrink it, I want to kind of compress it like you pushing a sandwich together. So this hump here, this little hump here, if I press down on it, it flattens. And the reason why it flattens is because this a this time is in between 0 and 1, which means it's a fraction. So if you have a fraction in front, this is where we're going to be shrinking vertically. Again, if we have the constant or the number in the inside of the function that's right beside the x, we're going to be doing shrinking horizontally this time with a whole number, and then stretching horizontally with a fraction. So again, this is what the black looks like. And if we kind of compress it like we're pushing it together, like we're closing our hands together, we're clapping, we're going to be using this one here. So a whole number means we're shrinking it. So we push it together with our hands and make this little red one here. And this one here, if we pull it apart, so this time we're taking this little black end, this little back end, and pulling it apart like a rubber band. We're stretching it. This is where the stretching horizontally goes, left and right. We're stretching it left and right. So we pull this one this way, we pull that one that way, and because we're using a fraction right beside the x. Here's another fraction beside the x. So again, if we have a fraction beside the x, we're going to be pulling this one apart, pulling this one this way, stretching it. And then if we have the negative in here, we're reflecting on the y-axis this time. So this is kind of like a rundown of each of these, what we're going to be doing to the equation. Now, here is an example that I want to show you. I can pull it up. So here we have two base functions. I have x squared and the absolute value of x. So just what it looks like, and I'll put it in black. This is a parabola, and this is going to make like a V when you graph it. So you can actually put this in your calculator and graph it. In y1, just go to y equals, and then in y1 you put in x squared, and then see what the graph looks like. You can hit zoom 0 or zoom 6, and then clear that out, and then put in the absolute value. You might have to click y equals, put in the x, and put the absolute value bars, and then we're going to see what the graph looks like. But for this directions here, I would like for us to expand vertically by a factor of 3 and translate down means shift down 3 units. So what would the equation look like if we were to do that? So I have y equals, and a factor of 3 vertically, that means I'm going to have a whole number in front. Here's my x squared is my base function, and then it's going to shift down 3. So I'm going to put minus 3 on the outside. So remember, anything on the outside of the function, we're going up and down. And then if it's in inside with parentheses, that's where we're going to go left and right. And the 3 whole number means that we're going to be expanding vertically. So over here, for this one here, I'm going to have my y equals. And this time, I'm going to expand horizontally. This time, a factor of 2. That means it has to be on the inside of the with the x. So a factor of 2 is going to be the 1/2 x, and then I'm going to put this in also in parentheses. Let me change that back. And then we're going to go to the right one. Remember, that's a minus because it's going to be on the inside. And then I'm going to put my absolute value there. So this here is expand horizontally, a factor of 2. So that's where we're going to get the 1/2 from. And then we're going to we're going to do shift right 1 unit. So remember, it's going to be the opposite. This is -1, we're going to go to the right one. Now I want to shift up 3 units. So because we're going up and it's on the outside of the function, we're going to put a +3. So this is what these are what my functions look like with the directions given. Oops, I didn't erase that. But this is what the function looks like when we're given.